Okay, guys, and so here's your podcast on single replacement reactions. These are also called single displacement reactions, and you can also call these substitution reactions. So just make sure that you know the possible names that this kind of reaction go under: single replacement, single displacement, or substitution reactions. Okay, and so these are pretty simple once you get a hang of them. In this reaction, an element that is by itself is going to replace some other element that's part of an ionic compound. And so our generic equation would be something like this: A plus BC. So here is your element right here, A. The element A is going to react with some compound, BC, and this compound here is an ionic compound. That's important to understand, that we have an ionic compound there. And what's going to happen is A is going to go over here and kick one of these out. It's either going to kick B out or it's going to kick C out. And which one it kicks out depends on the identity of A, what kind of element it is. And so if A is a metal, then it will go over here and kick out the metal, which is the first element. Remember, metals are written first in our compound formulas, and so A would kick out B, and B would come over here and be by itself. If, however, A were a nonmetal, then it would come over here and it would kick out the nonmetal of the compound C, and the nonmetal, the C, would come over here and be by itself. And so we're replacing an element that's part of the compound in this reaction. So that's your basics here going forward. And so in this case, A is acting as a metal, and so it's going to replace the B. So B comes out by itself, and A joins with C. So let's do an example. So sodium plus hydrochloric acid, or HCl. So you need to identify the type of element that sodium is, and so sodium is a metal, and so it's going to go and replace the metal. Now, the metal is always written first, and so you're like, well, hydrogen is not a metal. Well, that's okay. It's the first element written. It's the most metallic, and so that's what it's going to replace. So the sodium will go over here and kick out the hydrogen. The hydrogen will come by itself, and that's what we'll get. And so when hydrogen comes by itself as an element, remember it's diatomic, so there needs to be a 2 on it. So there's 2 hydrogens because hydrogen's diatomic, and now it's an element. And we're going to get sodium plus chlorine. So you do your charges on sodium and chlorine and do your crisscross charges here. So crisscross right there. And we get 1 sodium and 1 chlorine in our compound. So it's important that when you write the single replacement reactions and the double replacement, which is going to come up next, is that when you write the compounds over here in this section, that you do your crisscross of your ionic charges to get the correct formula, to get the correct subscripts down here. In this case, they're both 1s, but it's important to get the correct subscripts there. Otherwise, when you try to balance it, it's not going to work for you. All right, let's do balance this one. So we'll put a 2 on the HCl because we had a 2 on the hydrogen, and then we're going to put a 2 on the NaCl, and that's going to give us 2 sodiums, and we'll come back over here and we'll put a 2 on that sodium to balance that equation out. Alright, so again, animations just kind of give you visuals. So here's our 2 sodium atoms and our 2 hydrochloric acids. And the sodiums are going to go over here and they're going to replace the hydrogens. The hydrogens will happen to combine to form H2, so they'll come together. And so there we go. There's our 2 hydrogens, H2, and our 2 NaCl's here. Alright. Let's do a couple of practice on those. So H2 plus ZnCl2. What is hydrogen going to go over here and replace? So even though hydrogen is a gas, it's on the metallic side of the periodic table, so we're going to treat that as a metal. And it's going to go over here and it's going to replace the metal zinc. So let's do that. And so zinc comes out, and the hydrogen is going to combine with the chlorine, and hydrogen's charge is a 1 plus. And the chlorine charge is a 1 negative. So with the 1 positive and the 1 negative, you get an HCl molecule. To balance that, we're going to need to, we have two hydrogens over here, so we'll come over here and put a 2 on the HCl. That would give us 2 chlorines as well, which is how many chlorines we have on this side, and we have 1 zinc and 1 zinc, so that one is balanced. Second example, aluminum plus magnesium oxide. So once again, looking at what you've got here, aluminum is a metal, and so it will come over here and replace the metal magnesium. Magnesium will come out by itself. And so we're going to have magnesium by itself, and the aluminum will combine with oxygen, so we need to find their charges. So aluminum is right here in the 3 positive column, oxygen's right there in the 2 negative column. And so aluminum with a 3 positive, oxygen with a 2 negative. Now you're going to crisscross these charges. You'll get a 3 on the oxygen, you'll get a 2 on the aluminum, and you'll get Al2O3. And then to balance this, we have 2 aluminums over here and 3 oxygens over here. When you come back over here, put a 3 on the magnesium oxide to get the oxygens counted up. You put a 3 on the magnesium and a 2 on the aluminum to get those straightened out. And so there's your balanced equation for that chemical reaction. Double replacement is very, very similar. If you can do singles, you can do doubles. It's just now we've got 2 compounds instead of an element and a compound. Same thing happens though. Metal replaces metal. And so in this case, we can look here. You can see that the element A and the element C, these are the 2 metals. The first one's written. They switch places, so the C comes over here and is in front of B, so we get CB. And the A is over here and is in front of D, AD. Remember, metal's written first. Always write your metal element first. Another simple way to look at double replacement is really easy, actually. If you go to your math class and you've got some problem where you got to distribute this out, then they teach you the FOIL method. You do the first times the first, the outer times the outer, the inner times the inner, and the last times the last. Well, it's kind of like that in chemistry. For double replacement, we just do the middle though, the outer and inners. And so if you look at this, the outers, AD, go together, and then the inners, CB, go together. So outer and inner will get you the correct components. Just always make sure you write the metal first when you put it. So like you might write a BC. It might be a mistake to write B and then C. But C is the metal, so write it first and then write B. Okay? And so there's an easy way to do your products on a double replacement reaction. So let's do an example. NaCl plus KBr. So in this case, we're going to have the Na and the B and the K switch places. All right, so K will be with Cl and Na will be with Br. All of these are 1 plus or 1 negative charges. That's going to make it easy for us. And so we'll get a KCl plus a NaBr. And again, everything's a 1 plus charge. Makes balancing easy too. It's already balanced. So there you go, NaCl plus KBr, and let's have those switch places to make the new compounds. So that's our new elements, or sorry, not elements, our compounds. Another practice, so AlCl3 plus MgO, and so the Al, we could do the outer here, outer, Al will be with O, and we could do inner, the Mg will be with Cl, another way to look at it. And so we'll get AlO and MgCl, and we got to do our charges. So the Mg has a charge in the second column, 2 plus, and it's going to be with Cl, which is a 1 negative. And so when you get that formula, you'll get MgCl2, and the Al with a charge of 3 plus will be with the O, which is a charge of 2 negative. So you'll get Al2O3. And that is your equation for this chemical reaction. Balance that, put a 2 on the AlCl3 and a 3 on the MgCl2. You do that because we got a 3 here on the Cl and a 2 here on the Cl, so the least common multiple is going to be 6. So let's get the 6 by putting the 2 and the 3 there. And then finish this off with a 3 on the MgO. Last example, Li2O plus FeCl2. And so again, just switch them, switch the Li and the Fe, or do outers and inners. however you want to do it. We'll get the lithium and the iron. Actually, we're going to do the iron first. So the iron is going to be with the oxygen. Now, here's the issue with this. Iron's a transition metal, so this is one little trick on the double replacements. This is not always true, but we're going to consider it to be true for us here unless you do oxidation reduction reactions. We're going to keep the same charge. So what is the charge of iron? It's a transition metal. We know what its charge is. We're going to maintain the same charge that it was over here. And so our little technique was, let's find out what the charge of the chlorine was. It's a 1 negative. Do the 2 times the 1, that gives you 2, and then divide by how many irons you had. So we have an iron 2 plus here. Alright, so this is an iron 2 plus. It's going to be with the oxygen, which is 2 negative, and that gives us FeO. And then the lithium, which is a 1 plus, will be with the chlorine, which is a 1 negative, and that's LiCl. And then we're going to balance that. We'll put a 2 on the LiCl to get that one balanced. Okay, so that is single and double replacement. Not overly difficult. Just make sure you're basically doing nomenclature on the right side. Put the right elements together and write the metal first, then the non-metal, and do your crisscross on your charges to get the correct formula of the compound. All right, that's it for double replacements, and we'll see you later.